Hi everyone, welcome to our physics class. In the previous class, we have studied about purely resistive circuit. It means AC voltage is applied to a circuit containing only resistor is called purely resistive circuit. So, what amount of current flowing through purely resistive circuit? That is I is equal to I naught sine omega t. So that is actually the mathematical expression for instantaneous current flowing through a purely resistive circuit. So in purely resistive circuit, current and voltage are in phase. There is no phase difference between current and voltage. So what is the value of phi? Phi is equal to 0. And what is the value of power factor? Cos phi, that is exactly equal to 1 because phi is equal to 0. Okay, the power factor of purely resistive circuit is exactly equal to 1 because in purely resistive circuit, current and voltage are in phase. There is no phase difference between current and voltage. The value of phase difference between current and voltage is equal to 0. So the power factor cos phi is equal to 1. And the average power over one complete cycle, that is the product of RMS value of voltage and RMS value of current. So even the power loss is also the product of RMS value of voltage and RMS value of current. So this is alternating current part 3. Alternating current part 3. Okay, well, so let's start today's class. So today we are going to discuss about the next very important circuit, that is purely inductive circuit. That means the AC voltage is applied to circuit containing only inductor. AC voltage applied to an inductor. Okay, AC circuit containing pure inductor. Or show that the current lags behind the voltage by an angle 90 degree or pi by 2 radian, or show that voltage leads the current by an angle 90 degree. So this is a very important derivation for pi mark. Okay, first here, let's consider an inductor. So what is the meaning of inductor? Inductor is a circuit element, so which offers certain opposition to flow of change in current. It opposes the change in current. The resistor is a circuit element which offers certain opposition to the flow of current. So inductor is a circuit element which offers certain opposition to change in current. So inductor opposes the change in current, but it does not oppose the steady current. Okay, resistor opposes the flow of current. Inductor opposes the change in current. Okay, so AC voltage, that is V is equal to V naught sine omega t. AC voltage V is equal to V naught sine omega t. So that is applied to a circuit containing only inductor. Okay, AC voltage, that is V is equal to V naught sine omega t, that is applied to circuit containing only inductor. This is called a purely inductive circuit. What is this? Purely inductive circuit. What is the meaning of purely inductive circuit? AC voltage is applied to a circuit containing only inductor is called purely inductive circuit. Purely resistive means AC voltage is applied to circuit containing only resistor. That is purely resistive circuit. So this is purely inductive circuit. That means AC voltage is applied to circuit containing only inductor. What is the meaning of inductor? Inductor is a circuit element which offers certain opposition to the change in current. Okay, so it opposes the increasing current, it opposes decreasing current, it opposes the change in current, right? So when AC voltage that is applied to an inductor, so what happens? The current flowing through the inductor is gradually increases. The magnetic flux linked with the inductor will changes. Okay, as the current flowing through the inductor, it is gradually increases. What happens to the magnetic flux? The magnetic flux linked with the inductor is directly proportional to current flowing through the inductor. Is it not? So the current flowing through the inductor is gradually increases. The magnetic flux linked with the inductor is also gradually increases. So that is actually phi is equal to L I. L is the inductance of the inductor. What is the meaning of inductance? Inductance means the ratio of magnetic flux to the unit current. Unit current flowing through the inductor. Okay, what is this? Inductance. So whenever the magnetic flux linked with the coil changes, whenever the magnetic flux linked with the coil changes, what happens? EMF induced in the coil or inductor. So that EMF opposes the change in current. Okay, so whenever the magnetic flux linked with the coil changes, EMF induced, EMF induced in the coil, that EMF opposes further change of magnetic flux. Okay, so VL is equal to minus d phi by dt. This is according to Faraday's second law of electromagnetic induction. But what is the value of phi? Phi is Li, L is constant, theta is outside. So that is minus L into di by dt. What is this? This is the EMF induced in the inductor. Okay, so now let us start the derivation. Let and applied AC voltage, applied AC voltage is given by applied AC voltage is given by V is equal to V naught sine omega t. Call this as equation number 1. This is again a closed conducting path. So here we have to apply Kirchhoff's voltage law, right? We have to apply the Kirchhoff's voltage law to the loop. Okay, according to Kirchhoff's voltage law, in a mesh of an electrical network, algebraic sum of the product of current and resistance in different parts of the mesh is equal to algebraic sum of EMF in that mesh. Actually, this circuit doesn't have any resistance. Okay, that means the LHS part that is equal to 0. But algebraic sum of EMF. Here there are two EMF. One is applied EMF and another one is induced EMF. So one is V and another one is VL. Actually V is positive, so VL is negative because VL opposes the direction of current. Okay, so 0 that is equal to V. So VL is minus L into minus L into d I divided by dt. Okay, so L into di by dt, that is equal to V. V is V naught sine omega t. So actually we have to find out the instantaneous current flowing through the inductor. That means the current at any instant of time. So di, that is equal to V naught divided by L into sine omega t into dt. Okay. Now integrate on both sides. Okay. Integrate on both sides, and we get integration of di, that is equal to integration of V naught divided by L sine omega t into dt. So integration of di is I. V naught by L is constant, that is taken as outside. V naught by L integration of sine omega t into dt. So I is equal to V naught divided by L integration of sine omega t, that is minus cos omega t divided by omega. Okay, so V naught divided by L omega into minus cos omega t. So that should be converted into sine form. Actually, sine of pi by 2 minus omega t. So what is the value of sine of pi by 2 minus omega t? Sine of pi by 2 minus omega t is cos omega t, right? So here minus is taken as outside. So sine minus of omega t minus pi by 2, and the sine of minus theta is minus sine theta, right? So minus sine of omega t minus pi by 2. This is equal to actually cos omega t. So what is the value of sine of omega t minus pi by 2? Sine of omega t minus pi by 2. So that is equal to minus cos omega t. So minus cos omega t in terms of sine, that is sine of omega t minus pi by 2. Sine of omega t minus pi by 2. So I is equal to V naught divided by L omega. So this is actually called the inductive reactance. Okay, inductive reactance means the effective opposition offered by inductor to the flow of AC. So inductive reactance is the effective opposition offered by inductor to the flow of AC. So this is also measured in terms of ohm. Resistance is measured in terms of ohm. Inductive reactance is also measured in terms of ohm. This is inductive reactance. Inductive reactance means the effective opposition offered by inductor to the flow of AC. So V naught divided by XL into sine of omega t minus pi by 2. So R is equal to V naught divided by XL, that is actually the peak value of the current I naught. I is equal to I naught sine of omega t minus pi by 2. Now call this as equation number 2. So where I naught is equal to V naught divided by XL. So XL is equal to V naught divided by I naught. So this can also be written in the form of, we are divided by root 2 on both numerator and denominator. So V naught divided by root 2 is V RMS. I naught divided by root 2 is I RMS. Okay. The ratio of RMS value of voltage. The ratio of RMS value of voltage across the inductor to the RMS value of current flowing through the inductor is called inductive reactance. This is another definition of inductive reactance. So the first one is inductive reactance means the effective opposition offered by inductor to the flow of AC. The second one is the ratio of RMS value of voltage across the inductor to the RMS value of current flowing through the inductor. Okay, now comparing the two equations 1 and 2. Now comparing the two equations 1 and 2. We can conclude that comparing the equations 1 and 2. So we can conclude that current lags behind current lags behind current lags behind the voltage. So by pi by 2 radian, or in other words, voltage leads the current. Current lags behind the voltage, or voltage leads the current. So here current is I is equal to I naught sine of omega t minus pi by 2. So that is why current lags behind the voltage by pi by 2 radian, or voltage leads the current by pi by 2 radian. So here the phase difference between current and voltage, that is not equal to 0. In purely resistive circuit, actually the instantaneous current flowing through the resistor is I is equal to I naught sine omega t. So there is no phase difference between current and voltage in purely resistive circuit. But here there is a phase difference between the current and voltage that is exactly equal to pi by 2 radian. The phase difference between current and voltage is pi by 2 radian in purely inductive circuit. What is the meaning of purely inductive circuit? AC voltage that is applied to a circuit containing only inductor is called the purely inductive circuit. Okay, so here the power factor. What is the value of power factor in purely inductive circuit? Power factor means the quantity cos phi. What is the meaning of phi? Phi is the phase difference between the current and voltage, right? So the phase difference between the current and voltage in purely inductive circuit is pi by 2 radian. This is for purely inductive circuit. What is the value of power factor? Cos pi by 2. Cos pi by 2 is 0. Okay, so here the power factor is 0. So how does the inductive reactance depends on the frequency of the applied AC voltage? That is very important. Actually, the mathematical expression for inductive reactance is XL is equal to L omega. So this is actually measured in terms of ohm. So XL is equal to L omega in terms of frequency, that is 2 pi f, right? So here L and 2 pi is constant. The inductive reactance is directly proportional to the frequency of applied AC voltage. So how does the inductive reactance depends? How does the inductive reactance depends on the frequency of applied AC? That is directly proportional. Okay. As the frequency of applied AC voltage increases, what happens to the inductive reactance. So inductive reactance actually increases linear. Okay, as the frequency of the applied AC voltage increases, so the inductive reactance increases linearly. Okay, so here actually the frequency is taken along x-axis, inductive reactance is taken along y-axis. As the frequency of applied AC voltage increases, inductive reactance increases linearly. Okay, and for the flow of DC, what is the value of inductive reactance? And this is very important for DC. For the flow of DC, the frequency is equal to 0. Okay, for DC, what is the value of frequency? For DC, frequency is equal to 0. If frequency is equal to 0, what is the value of inductive reactance? That is equal to 0. Okay, so for the flow of DC, inductive reactance is equal to 0. How does the inductive reactance depend on frequency? That is directly proportional. Okay, so the next topic is time diagram and the phasor diagram of purely inductive circuit. Time diagram and phasor diagram of purely inductive circuit. So this is the phasor diagram, and this one is the time diagram. Okay, so this is a time diagram. This one is the phasor diagram. So first here, let us consider the instantaneous voltage and instantaneous current in purely inductive circuit. So what is the mathematical expression for instantaneous voltage? Is V is equal to V naught sine omega t, and instantaneous current, that is I is equal to I naught sine of omega t minus pi by 2. So this is a mathematical expression for instantaneous current flowing through purely inductive circuit. Okay, first at time t is equal to 0. So this is time diagram. What is the meaning of time diagram? Time diagram means diagram which represents the time varying voltage and time varying current. A diagram which represents the time varying voltage and time varying current. This is the time diagram of purely inductive circuit. Okay, so this is fits into the number of phases. Let's consider here. The first phase is 0. The second one is T by 4. Next one is T by 2. The last one is third one is 3T by 4. The last one is T. Okay, so this is 0. And here the phase is T by 4. This point, what is the phase? T by 2. Here phase is 3T by 4. At this point the phase is T. Okay, so at time t is equal to 0. So what is the voltage? Voltage is V is equal to 0. Time t is equal to 0. So omega t is equal to 0. That is why V is equal to 0, but the current is not equal to 0. I is equal to I naught sine of omega t is 0. So 0 minus pi by 2, that is minus pi by 2. Sine of minus pi by 2, that is minus sine pi by 2 minus 1. Means I is equal to minus I naught. So at phase T is equal to 0. The voltage is equal to 0, but the current is not equal to 0. That is minus I naught. The first phase at time T is equal to 0. So the voltage is equal to 0, but the current is maximum, but that is negative, minus I naught. Okay. And the next phase at time T is equal to T by 4. T is equal to T by 4. Omega t, omega is 2 pi by t in terms of time period into t by 4. So t cancels. 1's are 2's are. So omega t is pi by 2. So that is what the voltage. V naught sine pi by 2. Sine pi by 2 is 1. So V naught is maximum. Okay. The current I is equal to I naught sine of pi by 2 minus pi by 2. Pi by 2 minus pi by 2, that is 0. Sine 0 is 0, 0 and anything is 0. So at time t is equal to t by 4, the current flowing through the inductor is equal to 0, but voltage that is not equal to 0. Voltage is maximum. At this point, voltage is maximum. Is how much? Plus V naught. Plus V naught. Okay. And in the next phase, at time t is equal to time t is equal to t by 2. So omega is 2 pi by t, t is t by 2. So 2 cancels, t cancels. Omega t that is equal to pi. So omega t is equal to pi when voltage V is equal to V naught sine pi. Sine pi is 0, 0 and anything is 0. And the current I is equal to I naught sine of pi minus pi by 2. Pi minus pi by 2 is pi by 2, right? Pi minus pi by 2 is pi by 2. Sine pi by 2 is 1. So at time t is equal to t by 2. The current flowing is maximum, but voltage is equal to 0. The current flowing through the inductor is maximum, that is plus I naught. Time t is equal to t by 2. Current flowing circuit, inductive circuit is maximum. Okay, is plus I naught. But voltage that is equal to 0. And the next phase, in the next phase is at time t is equal to 3t by 4. So omega is 2 pi by t. So t value is 3t by 4. So t cancels. 1's are 2's are 3 pi by 2. So what is the value of sine 3 pi by 2? So it is minus 1. So here the voltage is negative minus V naught, and the current I is equal to 3 pi by 2 minus pi by 2. Okay, sine of 3 pi by 2 minus pi by 2. That is 2 pi by 2 sine pi. Sine pi is 0, 0 and anything is 0. The current is 0. So at time t is equal to 3t by 4. So current flowing through the inductive circuit is 0. And voltage is minus V naught. Voltage is minus V naught. Voltage is minus V naught. Okay. And in the last phase, that is at time t is equal to t. What is the value of omega t? Omega is 2 pi by t into t. T cancels. So the voltage is V is equal to V naught sine 2 pi. Sine 2 pi is 0. And the current I is equal to I naught sine of 2 pi minus pi by 2. Sine of 2 pi minus pi by 2. So what is LCM? LCM is 2. So 4 pi minus pi is 3 pi by 2. Sine 3 pi by 2 is minus 1. That is minus 1 into I naught minus I naught. I is equal to minus I naught. So time t is equal to t. The voltage is 0, but the current is minus I naught. Right? This phase current is minus. Okay, so this is about the time varying current and time varying voltage. This is called the time diagram. So what is the meaning of time diagram? A diagram which represents the time varying current and time varying voltage is called the time diagram. Okay, now this is the phasor diagram. What is this? Phasor diagram. A diagram which gives the phase relationship. A diagram which represents the phase relationship between the current and voltage. So these are the phasors. Phasors means the current and voltage are represented in the form of rotational vector. This is the direction of voltage. This is the direction of current. So what is the angle between the current and voltage? That is pi by 2. This is the phase difference between current and voltage. What is the phase difference between current and voltage in purely inductive circuit? That is exactly equal to pi by 2 radian. But here current lags behind the voltage, or voltage leads the current by angle pi by 2 radian. Okay, so this one shows the instantaneous voltage. Okay, this one shows the instantaneous current. Instantaneous current going through the inductor. So at this point, the current is maximum, that is plus Im. At this point, voltage, that is maximum, that is plus Vm, or V naught. Okay, that is the peak value of voltage. So in purely inductive circuit, the current and voltage are not in phase, that is out of phase. Okay, so current lags behind the voltage by angle pi by 2 radian, or voltage leads the current by angle pi by 2 radian. So this is the phasor diagram. This one is the time diagram of purely inductive circuit. The next topic, derivation of expression for average power over one complete cycle in purely inductive circuit. Derivation of expression for average power over one complete cycle in purely inductive circuit. Okay, so first here, let's consider instantaneous power. Okay, instantaneous power in purely inductive circuit. That is how much P is equal to V into I. Okay, instantaneous power in the purely inductive circuit is P is equal equal to EM. Is this instantaneous? Instantaneous power. Instantaneous power in purely inductive circuit that is given by T is equal to VI. So the instantaneous voltage is V is V naught sine omega T. Instantaneous current is I naught sine of omega T minus pi by 2. So T is equal to V naught I naught sine omega t, sine of omega t minus pi by 2, that is minus cos omega t. Actually, sine 2 omega t, sine 2 theta is 2 sine theta cos theta. Sine 2 omega t is 2 sine omega t cos omega t. So sine omega t cos omega t. So that can be written in the form of sine 2 omega t divided by 2, right? So minus V naught I naught sine omega t cos omega t means sine 2 omega t divided by 2. So after that we have to find out average power. Average power over one complete cycle. Okay, average power over one complete cycle. Let us apply the average on both sides. Average of minus V naught I naught by 2 sine 2 omega t. So here the constant terms that is taken as outside because average of constant is constant minus V naught I naught by 2 that is taken as outside. Average of sine 2 omega t. Okay, so average of a function, average of sine 2 omega t, that is 1 by t integration of 0 to t sine 2 omega t into dt. So 1 by t integration of sine 2 omega t dt, that is minus cos 2 omega t divided by 2 omega. The limits varies from 0 to t. So minus divided by 2 omega, this is taken as outside, minus 1 divided by 2 omega of cos 2 omega is in terms of time period 2 pi by t t. The limits varies from 0 to capital T. So minus 1 divided by 2 omega. So cos 2 into 2 pi divided by t. First we have to apply the upper limit capital T minus cos 0. Cos 0 value is 1. Okay, cos 0 is 1. So actually here PP cancels cos 4 pi. Cos even multiples of pi. Cos odd multiples of pi is minus 1. Cos even multiples of pi is plus 1. Okay. So this value is 1 and this value is also 1. 1 minus 1 is 0. 0 is anything is 0. So the average of sine 2 omega t, average of sine 2 omega t, that is 0. Okay. Average power over one complete cycle in purely inductive circuit, that is equal to 0. And what is the power loss in purely resistive circuit? In purely resistive circuit, the power loss is ERMS, the product of RMS value of voltage, ERMS and IRMS. But in purely inductive circuit, the power loss is equal to 0. That means there is no power loss takes place across purely inductive circuit. So average power over one complete cycle in purely inductive circuit, that is equal to 0. Okay. Okay. Thank you.